Welcome to our beginner's guide to Arduino programming. In this video, we'll cover the basics of Arduino, some sample projects, and more. Let's get started. First, what is an Arduino? Arduino is an open-source electronics platform based on easy-to-use hardware and software. It is used to create interactive projects involving sensors, actuators, and other electronic components. Brief history. The Arduino was created in 2005 by Massimo Banzi and David Quartiels, building upon the work of Hernando Barragán at the Interaction Design Institute Ivrea in Ivrea, Italy. Why Arduino? First, it is inexpensive. Arduino boards are affordable, with even the basic version costing less than $50 and allowing hand assembly. Second, it is cross-platform. The Arduino IDE runs on Windows, Mac OS X, and Linux, providing cross-platform compatibility uncommon in many microcontroller systems. It also has a simple, clear programming environment. Offering a user-friendly interface for beginners and advanced functionality for experts, the Arduino IDE is based on the accessible processing environment, making it ideal for educational purposes. Next, Arduino software is open source, allowing for expansion through C++ libraries and facilitating the transition to AVRC programming, while also enabling direct integration of AVRC code. Lastly, it has an open source and extensible hardware. With hardware plans under a Creative Commons license, Arduino encourages the creation of custom modules, from advanced designs by experienced engineers to basic breadboard versions for educational purposes. Serial communication. Serial communication allows Arduino to send and receive data with a computer or other devices over a serial port. The Arduino IDE includes a built-in serial monitor for viewing and debugging serial data. Basic syntax. Arduino programming uses a simplified version of C or C++ language. Some basic syntax includes variables, which are containers for storing data, declared with a data type and a name. Data types, which can be stored in variables, such as integers, int, floating point numbers, float, characters, char, and Boolean values, bool. And control structures, which are used to control the flow of execution in a program, including if statements, loops, for, while, and functions. As you start experimenting with Arduino, you may encounter some challenges. Here are some troubleshooting tips to help you along the way. First, check connections. Ensure all connections between the Arduino board and components are secure and correct. Second, select correct port and board. Verify that the correct COM port and Arduino board type are selected in the Arduino IDE. Third, read error messages. Pay attention to any error messages or warnings displayed in the Arduino IDE, and use them to troubleshoot issues. Last, online resources. Utilize online forums, tutorials, and documentation to find solutions to common problems encountered during Arduino projects. Now, let's put everything we've learned into practice with a simple project. Here are some sample projects. Project 1. Write a sketch that applies bonus scores to given scores in the range 1 to 9. The program reads a digit as an input. If the digit is between 1 and 3, the program multiplies it by 10. If it is between 4 and 6, multiply it by 100. If it is between 7 and 9, multiply it by 1000. If it is 0 or if the value is not a digit, the program must report an error. Create two program versions, one that uses a switch statement and the other one that uses a nested if-else statement, and at the end print the calculated new value in the serial monitor. In this sample project, we'll explore two methods of handling input scores and calculating new scores using nested if-else statements and the switch solution. Let's start with the nested if-else statements approach. First, in the setup function we initialize serial communication with a baud rate of 9600. Next, we prompt the user to input a score via serial communication, then read and store the input score. We display the original score and call a function to calculate and display the new score based on specific conditions. If score is from 1 to 3, new score is equals to original score times 10. If score is from 4 to 6, new score is equals to original score times 100. If score is from 7 to 9, new score is equals to original score times 1000. The score bonus function validates the input score and calculates the new score using nested if-else statements. Let's attempt to execute the code. Now, let's start compiling the code. Then upload. Under the Tools tab, click Serial Monitor to run the program. Let's enter numbers from 1 to 3 to test if the program will multiply it by 10 as expected. Next, let's test the numbers from 4 to 6 to see if the program will multiply it by 100. Now, let's try numbers from 7 to 9 to see if the program will multiply it by 1000. Let's also try 0 to see what happens. It says error. This is because it only expects inputs from 1 to 9. Now, let's explore the switch solution. In the switch solution, we handle different input score ranges using separate cases. We have cases for scores ranging from 1 to 9. Each case calculates the new score accordingly and prints it. Let's compile and upload. Using the same inputs, let's see if the program will provide the same result. As you can see, the code provide the same results. Both methods ensure proper handling of input scores and display the corresponding new scores based on predefined conditions. Project 2. The colors red, blue, and yellow are known as the primary colors because they cannot be made by mixing other colors. When you mix two primary colors, you get a secondary color, as shown here. When you mix red and blue, you get purple. When you mix red and yellow, you get orange. When you mix blue and yellow, you get green. Write a sketch that prompts the user to enter the names of two primary colors to mix. If the user enters anything other than red, blue, or yellow, the program should display an error message. Otherwise, the program should display the name of the secondary color that results by mixing two primary colors. In this code, we're exploring color mixing using primary colors. The setup function initializes serial communication, prompting the user to input two colors via the serial monitor. We verify whether the entered colors are primary colors and then proceed to generate the secondary color based on the color mixing rules. We've defined an array of primary colors, red, blue, and yellow, and a function to check if a given color is primary. The secondary color generator function calculates the result of color mixing based on the entered primary colors. Now, let's start compiling the code. Then upload. Under the Tools tab, click Serial Monitor to run the program. Now, let's enter the first color as red and the second color as blue. Here we get purple as a result. Let's try another one. We're using red again, but this time, let's mix it with yellow. This time we get orange. Now, let's try to mix blue and yellow. Here we get green. Let's do yellow and white. We received an error, since white is not a primary color. Project 3. Write a sketch that displays the following menu. If the user types Y or Y, then the program redisplays the menu and asks the user to enter their choice. Otherwise, the program should now exit. If the user enters 1, the program should ask for the radius of the circle, and then display its area. Use 3.14159 for pi and the radius of the circle for r. If the user enters 2, the program should ask for the length and width of the rectangle and then display the rectangle's area. If the user enters 3, the program should ask for the length of the triangle's base and its height, and then display its area. If the user enters 3, the program should ask for the length of the triangle's base and its height and then display its area. If the user enters 4, the program should end. Input validation. Display an error message if the user enters a number outside the range of 1 through 4 when selecting an item from the menu. Do not accept negative values for the circle's radius, the rectangle's length or width, or the triangle's base or height. Implement the program using functions on it. One function will be used to display the menu screen and the other functions are for the different computations the program will have. You can see that I have already laid out the code and I'm going to give you a little tour. As the problem needed functions, I have created a function called displayMenu which displays the 4 choices that are asked to the user to initiate the area calculator. As we scroll down, you can also notice the use of switch cases. In this case, it is easier to look at instead of using else if. You can see the different functions used for this program, like the prompt continue function where the program repeats itself. From this point, I have already laid out the different functions that are needed to calculate the areas of geometrical shapes. We are now going to verify our code at the upper leftmost corner, and as you can see it is now done compiling. After verifying, we are now going to proceed for uploading the code with the arrow besides the check button. To see if the program works, there must be a serial monitor tab besides the output tab appearing. Now, we are going to type 1 to calculate the area of a circle. Entering the value 1, we can see that the area is 3.14. The prompt then appears if I would like to try again. I typed Y to continue the program. Then I'm going to enter 2 to calculate the area of a rectangle. Entering the length as 50 and the width of 20. I get area of 1000, which is correct. Now, choosing the calculator for the triangle. Entering the base as 50 and height of 20. I get area of 500. This program demonstrates the simple programming done using the area calculators and with the help of switch statement. Project 4. Write a sketch that prompts the user for 4 test grades. It will be used to determine if a student earned an A, B, C, D, or F in the class, using the following grade cutoffs. A student can drop the lowest exam score of the 4 exam scores. Therefore, the program should find the average of the 3 highest grades and print this average. It should also print a message stating the letter grade they earned in the course. Thoroughly test your program with data that calculates a grade for each letter grade. Also be sure that the lowest grade is not included in the calculation independent of whether it is the first, second, third, or fourth test score entered by the user. I have already implemented the code and I'm going to show you tidbits to demonstrate how the program works. With the use of else-if statements, this calculates the rating of the students. Of course, we need conditional statements to get the rating. After that, we are going to verify the code with the check button on the upper left corner of the IDE, and it is now done compiling. Right besides the check button is the upload button where we upload our code to the Arduino. Until it is done uploading, we now click Tools, then Serial Monitor. The program shows that prompt for the first exam. This follows the requirement of the project and asks for the first of 4 exam scores needed to calculate the average. I have inputted the 4 exams and we get the same output as the sample run for the project that is given. That's all. Thank you for watching.